So this is number 8 from the homework that you did. They gave you the point -1, +7. Then they gave you the equation of the line, y equals 3x. They want you to find the distance from this point to this line. The distance is going to be that perpendicular segment. But what we need to do is find the equation of the line that's perpendicular in between this point. So, for example, let me just give you like a rough sketch of this. So let's say this is the order pair, 1, 2, 3, 4, 5, 6, 7. And then the equation of y equals 3x, this is going to be, notice the y-intercept here, there's nothing here, so you start at 0, 0. I'm going to rise 3 and run 1. And then I could also go down 3. Let's see. This is just a rough sketch just to show you. So what we're trying to do is find the distance between this point and this line. And remember, it's always the perpendicular distance. So what I'm really trying to do is find the equation of that line. And the way that I'm going to do that is I know that perpendicular lines have opposite reciprocal slopes. So what I'm taking out of the equation they gave me is the slope. The slope of this line is 3. But the slope of a perpendicular line is going to be -1/3. And now I'm going to use the order pair, and I'm going to plug that in to y equals mx plus b. So I'm going to plug in, this is x, this is y. So I'm going to plug in 7 is equal to -1/3 times -1 plus b. 7 is equal to +1/3 when I multiply that. Then I have to move the 1/3. And I get 6 2/3 is equal to b. So the equation of the line is going to be y equals, I'm now going to plug back in the slope and the b into this equation. So all I'm going to put in is the slope and the y-intercept. So if you think about it, let's see, this is 1, 2, 3, 4, 5. So about 6 2/3 is right there. And then they move the slope up 1/3. And then that's how they can find, if you wanted to graph it, you could figure out what the point of intersection is by graphing it as well. But I'm going to go ahead and do it mathematically because sometimes your graphs are off and it's kind of hard to find the point of intersection. So now what I need to do is I need to take the two equations, the given one and the newly formed one. I'm going to use the method of substitution and I'm going to set these two equal to each other. So I'm going to take 3x and set that equal to 1/3 x plus 6 2/3. I need to group my like terms. So I'm going to move the x over. This now gives me 3 1/3 x is equal to 6 2/3. Now, if you recall back from 4th grade, when you divide mixed numbers, you need to make them improper. Don't try to make these decimals because it's a repeating decimal. So I'm going to make it an improper fraction. The way that you do that is you multiply the denominator times the whole number plus the numerator. So 3 1/3 becomes 10/3. 6 2/3 becomes 20/3. I'm now going to divide both sides by 10/3. Remember, dividing is like keep, change, flip. I'm really just multiplying by the reciprocal. So that's what I'm going to do. This is how I teach it to my Algebra 1 class. I just tell them to take the reciprocal of this, and then you're going to multiply both sides by it. Because this all cancels, becomes all ones. So I'm just left with x. And then this will also simplify. 1, 1, and a 2. So the x of my point of intersection is the order pair 2. Yes. So what you're doing is you have these two equations. You have the original equation, and then you have the newly formed one. So what I'm doing is I'm solving this system of equations. And when you solve a system of equations, you're trying to find the point where they cross. And the way that you were taught in Algebra 1 is either to use graphing, graph the two lines and then find where they cross, or use the substitution method or the elimination method. I'm doing the substitution method because I have both of my equations set equal to y. So all I did was I took what y equals and I put it in here. So now I only have one variable in my equation. So then that's how I turned it into this. So I took out the y and I replaced it with the 3x. Does that make sense? Yeah. So then now what we need to do is find, we're looking for an ordered pair. So far, I only have the x of my ordered pair. I now need to find the y. And I find the y by plugging it back into this one or this one. It doesn't matter. I'm going to definitely pick the easier one, and I'm going to plug it into the y equals 3x. So I plug in 2 for the x, and the y of my ordered pair is 6. Now I can finally do the distance formula using the original ordered pair, which was -1, 7, and the newly found point of intersection. Distance formula, x2 minus x1 squared plus y2 minus y1 squared, all under the radical, -3 squared plus 1 squared, square them, add them. On the test, you're going to leave it as the square root of 10. Last night in the Big Ideas homework, it said to enter it as a decimal rounded to the tenths place, so 3.2. So this is number 9 from last night's homework. The ordered pair that was given is 15 and -21, and the equation that was given is 5x plus 2y equals 4. Now, remember, what I need from this equation is the slope. It's not in slope-intercept form, so I need to rearrange it. So I'm going to subtract 5x from both sides. 2y is equal to -5x plus 4. Divide everything by 2. And y equals -5 over 2x plus 2. The slope of this line, the original, is -5 over 2. I want the slope that's perpendicular, so the perpendicular slope is going to be flipped and opposite sign. So the perpendicular to that would be 2/5. I'm going back and using my original ordered pair, and now I'm going to plug in these three things into y equals mx plus b, because I need to get the perpendicular equation. So we're going to get -21 equals 2 over 5 times 15 plus b. 2/5 of 15, again, I can simplify here, and this gives me 6 plus b. I'm going to move the 6, and my y-intercept of my perpendicular is -27. So my equation for the perpendicular line is 2 over 5x minus 27. I now take the two equations, this one, and set them equal to each other, because now I'm going to find the point of intersection. So I'm going to set -2/5. Doesn't matter which one goes on which side. And now I'm going to move my like terms together. So I'm going to add 5 over 2, and this has an x, 5 over 2x to both sides. Here we go again with your 4th grade fraction skills. I need to find a common denominator. My common denominator is going to be 10. So this ends up becoming 25 over 10. And then, because I times it by 5 to make it a 10, this one times by 2. So 4 over 10. When I add them, I get 29 over 10x equals, or let me wait, minus 27 equals 2. Now I need to get the 27 on the other side. 29 over 10x equals 29. I now need to divide by 29 over 10. Again, I like to just put the reciprocal, because that's what I'm doing, multiplying by the reciprocal when I divide. Notice what's nice is all of this just becomes an x. 29s also cancel. So the x of my intersected point is 10. And now I need to plug it back into one of them to get the y. Doesn't matter which. So I can either take it, plug it in here, or here. I'm still going to get the same y value. So if I plug it in to this one right here, y equals 2 over 5x minus 27. I'm going to plug in a 10. 2/5 of 10 is 4. 4 minus 27 is negative 23. So my point of intersection is the order pair 10, negative 23. I'm going to go back and grab my original order pair. And now I can do the distance formula. x2 minus x1 squared plus y2 minus y1 squared, all under the radical. 15 minus 10 is 5. This turns into negative 21 plus 23, which is positive 2. I'm going to square them. I'm going to add them. And then on the test, you would leave it square root 29. In big ideas, you round it to 5.4. Yes. All right, so number 10. This one, it said, let's see what it says. All right, it gave you 2 points. It gave you P and it gave you Q. The first thing it asked for was to find the midpoint. So we needed to remember the midpoint formula. You're going to add the x's, divide by 2, add the y's, divide by 2, and the coordinate of the midpoint is going to be 0 over 2, and this is going to simplify to 0, 1. So this was the first part that you would have entered in to big ideas for. This is the midpoint between these two order pairs. The next thing they wanted you to do was write an equation of the line that passes through the midpoint and is perpendicular to PQ. So remember, perpendicular, what we need to do is find that perpendicular slope. So the first thing I'm going to do is find the slope of PQ and then flip it to its opposite reciprocal. So the slope, I'm going to subtract, and it'll be negative 1 minus 3 over 4 minus negative 4. Gives me negative 4 over positive 8, which simplifies to negative 1/2. I need the perpendicular slope, so I flip it and make it positive. So the slope I'm using is 2, and now I'm going to use the midpoint and plug this into y equals mx plus b. Now, if you realize that this is actually the y-intercept right here, this order pair, but I'm going to go through the process. So 1 and then 2 for the slope times the 0 of the midpoint. 1 equals 0 plus b, and then 1 equals b. So the y-intercept is 1. So my equation of the line using my newly calculated b and the slope is going to be y equals 2x plus 1. And that's what you would have entered for the equation of the line for number 10. So for number 6, it was giving us the point 0, 0, and the equation y equals negative 9x minus 1, and they want the perpendicular equation. So the first thing I'm going to do is grab this slope, and I'm going to make it opposite reciprocal. So the slope I'm using is 1/9. And now what I need to do is find the equation. Well, my y-intercept is going to be 0, 0, but just to show you how you plug it in, y equals mx plus b. Remember, this is x, this is y. 0 equals 1/9 times 0 plus b. I get 0 equals 0 plus b. So my y-intercept for my perpendicular equation is also 0. So the equation of the line going through 0, 0 is y equals 1/9 x. Line should look like. So when you're graphing these, just a real rough sketch. So for this one, let me do this one in blue. Your first point should have been on -1. And then from there, my slope was -9/1. So what I needed to do is either go down 9 and over 1. I could also go up 9 and to the left 1. Let me add some little markings here. Actually, I'll just do them in pink. So 1, 2, 3, 4, 5, 6, 7, 8, 9. And then I would go up. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and then 1 over here. So the graph of the original equation looks like that. And then the other one, I'll do it in red. You start at 0, 0, and I'm going to rise 1 and run 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So if I go up 1 and over to the right 9, and then connect your points. And that's what the graph should have looked like. So you should have graphed the ordered pair like 9, 1 and 0, 0 for this one. And then for the blue one, you would have done 0, -1. And then this one would have been -1, 8. And then connect the points. Is that what you did? Okay. So that's what you had to do. You were expected to graph both the original and the other one. And then I know this is kind of rough because I didn't do it on graph paper, but these are perpendicular because they're slightly over. So again, practice this. Test is Tuesday. Again, I'm going to post the warm-up. And I'm also, the quiz review, or not the quiz, the test review is already on Big Ideas. And it's got an assignment where you're going to turn it in. The other review I'm going to post will have an NG in it, so you'll know that you don't need to turn it in.